Hey, math fans, welcome to section 4.2. We're on day 6. Let's get started. Today we're going to talk about experiments and what can go wrong. A lot of things can go wrong in an experiment. More specifically, we're going to talk today about what is the placebo effect and how can we prevent the placebo effect. More specifically, we're going to look at what is called the double-blind experiment in order to prevent that placebo effect, or at least minimize the placebo effect. So what is the placebo effect? Let's pretend there's a new drug that's supposed to help people with high cholesterol. In a normal test, the experimenter would administer the drug to the patient and measure whether or not the patient's cholesterol goes up or down, and therefore would try to establish a cause and effect relationship. However, we now know that that's a bad idea because you need something to compare it to. But more importantly, I want to talk about this thing called the placebo effect. The placebo effect is when you administer a drug or something to humans, some sort of treatment to humans, even if it is a fake treatment. In other words, if this doctor here gave the patient a sugar pill, the person would get better or their cholesterol would get lower due to this thing called the placebo effect. Just because they know that they're getting a drug, even though it's fake, but they don't know it's fake, just because they think they're getting something that will help them, the placebo effect actually will make them get better. So we have to prevent for that. The placebo effect only happens with humans, not with things, just with people. So when you're imposing a treatment on humans, make sure to take into account this placebo effect. So let me show you how to prevent that. So to prevent the placebo effect, what you could do is you could give half of your group the treatment, the real treatment, and then half of your group what is known as the fake treatment or the placebo. Usually it's like a sugar pill. But there's still a problem with this. You would think that this would work. You would think that just, not letting the person know which one they're getting, because this is called single blind. When the people don't know whether or not they're getting the real treatment or the placebo, that's a single blind experiment. What happens is that the person who's administering, if they know, oftentimes the other people can tell just by facial expressions whether or not they're getting the treatment or placebo. Because a lot of these circumstances are like life and death. And usually the person administering the drug has compassion for the patient. They usually have a relationship with them. And they care for their patient. And so sometimes the little facial expressions, like if you knew that you were giving your patient the placebo, you feel a little bit sorry for them. And so what they realized is the placebo effect still had an effect there. So what's the best thing to do in that scenario? That's right. Let the person give, whoever's giving or administering the drug shouldn't know either. So who knows who's getting which pill? You have a person in the back that has numbers and has all of these treatments and placebos kind of coded. They give that to the doctor or whoever's administering the drug, but they don't tell them which one is which. They just have a series of numbers and then they administer the treatment or the placebo to the person. That is called double blind, when both the doctor and patient do not know which treatment is which. And then that way no one can read the facial expressions. The placebo effect is really minimized. Another vocabulary word that you are going to hear quite often in this class is the words statistically significant. Please write this down and please understand what this means. It's going to come up more and more, especially towards the end of the semester. So what is statistically significant? An observed effect that is so large that it would rarely occur by chance is called statistically significant. A statistically significant association in data from a well-designed experiment does not imply causation. Let's take a look at an example. So take a moment and read page 249 to 250, the distracted driving activity. Go ahead and pause the video, make sure you've read this, and then I'll explain what the activity is all about. If you were on your cell phone, there were 12 people that did not stop at the rest area, versus if they weren't on their cell phone, it was just a passenger in the car, only 3 missed it. And you can kind of see, this looks pretty, this makes me think that maybe if you were on your cell phone, you're gonna definitely be more likely to miss the rest area. But the question is that due to just random chance? Could that have happened just randomly? So the activity is about this. How can we simulate random chance given the same scenario? So what we would do, if we were in class, what I would do is I would give each of you guys slips of paper. And on 33 of the slips of paper, because 33 people actually stopped, whether or not they were on the phone or they just had a passenger in a car, 33 people stopped, okay, at the rest area, where 15 of them actually were distracted. And my question is that what we're going to do is I would have you guys shuffle the cards, and then I would ask you what would happen just due to random chance. So you would take all of the yeses, all of the nos, and you'd have some yeses, you'd have some nos in here, you'd have 33 yeses and 15 nos, and then you would randomly place half of the group into the cell phone and then half into the passenger group. So after shuffling these 33 yeses and 15 nos, shuffling them, you would assign half of them to the cell phone group, half of them to the passenger group, and you would count the number of nos in each group. That means that they were distracted. My question to each of the groups in class would be, did you get 12? Or how likely is it that you would have gotten 12? Because that's what the study came up with. And so if we were to repeat this process 100 times, and basically whatever your group got, let's say you got 5 no's or 7 no's or 12 no's, I would have you do it on a dot plot, and your dot would be represented on this dot plot in the front of the classroom, and we could all see the results. If we were to do this 100 times, let me show you what the results would look like. The results would look like this. Notice out of 100 times, only 12 only came up once due to random chance. That's extremely unlikely. In fact, that's a 1% probability that this would have happened due to random chance. This is what we call statistically significant. If you do a simulation like this, or if it's just due to random chance that something happens, and write this down, if it is less than 5%, which 1% is less than 5%, we would consider it statistically significant. And that's going to do it for this section. We'll see you in class.